All right, so we're on lecture 10, part C. So part C, I'm going to be reviewing because I have to say this is one of the most challenging topics we do, all this naming business. The best advice I can give you is you got to practice. Like practice, 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 practice. The more you practice, the better you'll get at it, and the more it'll make sense. All right, so like I'm hoping these videos help you out. But you got to practice, and if you start to practice and you realize, man, I'm confused, well, watch these videos again. That's my best advice for you. So this one, I'm going to kind of review everything. I'm not going to necessarily go over every single detail, right? That's what all the other ones were for, but I want to give you some reminders about how to do these. All right, so we're going to, in a minute, I'm going to give you a few practice questions, and I'm going to give you a bunch of formulas, like, I don't know, I might give you, I don't know, like a SBR2 or something. And I'm going to say, hey, tell me the name of that. So before we try any like that, where I give you a formula and I want you to write out the name, let's kind of go over a little review of what we've covered. So far, we've learned that there are three kinds of compounds: ionic, molecular, and acids. They all are made up of different things. They're all named different ways. So if you can't recognize what kind of compound you're dealing with, you're not going to know how to name it because every category is named differently. So in this case, the way that I'm going to know how to name things is I'm gonna have to recognize what do I find in the formula. So like in the formula of an ionic compound, a molecular compound, and an acid. So if I give you a formula of an ionic compounds, remember, are made up of a metal and a nonmetal. Something from the left-hand side of the periodic table, something from the right-hand side of the periodic table. Something on each side of the staircase, a metal and a nonmetal, both sides of the periodic table. Now, how are you going to know if you're looking at the formula of a molecular compound? You're going to see two nonmetals. Two nonmetals. All right, if all you see is stuff from that top right corner of the periodic table, if all you see is stuff from the top right corner of the periodic table, it's molecular. If it's an acid, the way you're going to know it's an acid is it's going to start with H. If you see a formula and it starts with hydrogen, it's an acid. All right, so you got to know the category. If you don't know the category, you're not going to know how to name it because they're all named different ways. All right, so let's figure out the category, and then let's worry about naming it. So let me kind of remind you a little bit about the naming. What do you do once you realize, oh my God, I got an ionic compound? These are the ones where you have to worry about charges. These are the ones where you might need a Roman numeral, right? If it's somebody who can make more than one charge, a metal that can make, I'm miswriting the word there, that can make more than one charge, you use Roman numerals. Numerals. There we go. All right, molecular. What do I do? I got a molecular compound. What am I supposed to do? If all I see are two nonmetals, these are the ones where you use your prefixes. Mono, di, tri, tetra, penta, that stuff, right? All right. And then, there's more details, so we'll get to those when we get to our examples. But remember, those are the prefix ones. Now, as far as acids, acids. Oh, I got a formula that starts with H. What do I do? You use the conversion thing. Oh, if the non-hydrogen part ends in "ide," hydroic. If it ends in "ite," you're going to switch it to "us." If it ends in "ate," you're going to switch it to "ic." And now they all are going to end in acid, right? All right, so that's just kind of the highlights to kind of refresh your brain about all this stuff, because man, it is confusing, isn't it? There's a lot to keep track of. So let's do some examples. And this time, instead of telling you it's ionic or molecular or an acid, I'm going to have them all mixed up, and you're going to have to figure out what you got, and then we're going to figure out how to name them. All right, so that's what we're going to do on the next slide. Let me go ahead and get to it. All right, so I got our handy dandy handouts out. I got our polyatomic list. We're gonna need that once in a while. And we're gonna need our periodic table, right? Our periodic table. All right, so let me put up a few examples and then we're gonna go through them. So here is a list of formulas. MgBr2, what are we gonna call that? And how about COSO4? And while we're at it, HNO3. And while we're at it, P2O5. All right, so the first thing I want you to do, I'm not even going to try to name these things yet. I want you to figure out the category they're in. All right, what category are they in? So if I was you, you might even pause this for a second and see if you can figure it out. When you look at those four formulas, do I have an ionic compound or molecular or an acid? All right, let me have a sip of something to drink too. It's a soft drink. Don't get all excited. I'm just trying to stay hydrated while you're thinking. Again, it would be really helpful if you paused this and tried to think about it. All right. Well, let's see how you did. All right. First one, MgBr2. Let's kind of figure out the category. Mg is right here. It's a metal. If you got a metal in you, and the other thing's a non-metal, by the way, bromide is a non-metal. If you got a metal and a non-metal, this thing is ionic. All right. Now, for our next example, COSO4. CO is right here. It's a metal. And SO4 is actually a few nonmetals. So it's like sulfur and oxygen, right? So we got metals and nonmetals. Metals and nonmetals, ionic. All right. Now, how about the next one? Oh, the next one, HNO3. HNO3? That's an acid. And then, if it starts with H, and then P2O5. Oh, let me erase some of this from my last one. P is right here, and then O5, O. Now, they're both on that top right corner. They're both nonmetals. This thing is molecular. All right, so let's go over them. All right, now, I think, honestly, I'm going to go over them. Maybe I'll go over them in a little different order. Let's start off with molecular. I have to say molecular, to me, they're the easiest ones. Maybe you don't find the easiest, but to me, they're the easiest ones, right? Because the molecular ones, that's where you use those prefixes, and that's all you need to do, all right? So you tell me the name of the first element, you tell me the same of the second element. Now, that one will get an "ide" ending, the second element, and then you're going to use prefixes to tell me the amount. So what does P stand for? P is phosphorus. O is, you're going to tell me the name of O. O is oxygen. But don't say oxygen. It should end in "ide," right? The second element should end in "ide." So it's oxide. And then you're going to tell me how many of each. So there are 2 phosphorus, diphosphorus, and then 5 oxygens, pentaoxide. Pentaoxide. All right, diphosphorus pentaoxide. Did I do that right? Yeah, it's molecular. Only nonmetals. Yep, just these nonmetals. And then you write the name of the first element normally, phosphorus. You write the name of the second element with that "ide" ending, oxide. And then the prefixes tell you the subscripts, or the subscripts tell you the prefixes, diphosphorus pentaoxide. All right. I don't know. Which one should we do next? I guess it really doesn't matter, huh? Let's, what the heck? Let's do the acid next. That's the next one up. All right, for the acid, you figure out the name of the non-hydrogen part. This part right here, NO3. The non-hydrogen part is NO3. NO3, element or polyatomic? Element or polyatomic, NO3? It's a polyatomic, right? It's a bunch of atoms. It should be on the polyatomic list. NO3, is it? Oh yeah, it's right here. NO3. It's called nitrate. All right, so the acid that contains nitrate. So NO3 is called nitrate. 8, you turn it into, oh, how did that work again? 8, take off the 8, replace it with ic. So this acid, 8 and ic go together. This would be called nitric acid. Nitric acid. All right. Let's do the last two. The last two are ionic. So these are the ones where you write the name of the metal, followed by the name of non-metal. Maybe you need a Roman numeral, right? So we're not doing prefixes. That's molecular. We're not going to be doing like the conversion thing, the little acid thing. They aren't acids. The top 2 are both ionic. Let's see if we can figure out the name of them. You write the name of the first thing. Mg. Mg is called magnesium. You write the name of the second thing, Br. Br is called not bromine, when it's part of a compound, it's got a negative charge, so bromide, magnesium bromide. For ionic, no prefixes, just magnesium bromide. Oh, wait a minute, there could be a Roman numeral. Let's see. Magnesium, do you need a Roman numeral? No, you don't. You don't need a Roman numeral because it's an always and forever, right? So no Roman numeral, there are always one. No Roman numeral, there are always two. And these fellas don't get Roman numerals either because they always had the same charge in every situation. So it's just magnesium bromide. Done. All right. Let's erase it. Let's do our last one. COSO4. COSO4. So for that one, we're going to do the same idea, all right? We're going to write the name of the first element, name of the first element as normal, and then we'll write the name of the metal, and then followed by the name of non-metal with the Roman numeral. I got a little tongue twisted there. All right, so what do you call CO? CO is called cobalt. All right, and then SO4. That is not on the periodic table. SO4. It's a few atoms, right? SO4. It's a polyatomic. So, in fact, it is right here. It's called sulfate. So this is going to be called cobalt sulfate. Now, for ionic, there's only one more thing to check. And that is, do we need a Roman numeral? So let's figure out where that cobalt is. Right here. Oh, yeah, it's in the middle. The middle ones basically need the Roman numerals, don't they? So we need to figure out what that Roman numeral is going to be. There's going to be a Roman numeral right here. All right. So how do you do that again? You look at the charge on, maybe I'll do this as a little scratch work, on the thing it's bonded to, SO4, and the polyatomic list right here, it tells me that it's actually -2. So the cobalt will be whatever charge it takes to balance, right? You got to have the pluses and the minuses even. So the cobalt is 2. All right, it's going to be Roman numeral 2. Cobalt 2, because if sulfate's -2, to balance it out, the cobalt has to be +2. All right, so yeah, there's a lot to keep ahead, right? Molecular prefixes, please. Acids, change the ending, please. 8-ic. And then for ionic, that's where you might need the Roman numeral. All right, no prefixes though, no prefixes. All right, so let's just do a couple going the other way. All right, let's keep on going. Let's do a couple going the other way though. Let me, if I give you the name, can you write the formula? Oh, let's practice that. Let's make sure we got that figured out. All right, moving on to the next slide real quick. All right, so last couple, we're going to go the other direction. I'm going to give you the name. You're going to write the formula. All right, so I got my two handy-dandy handouts still, my periodic table, my good old friend, and my polyatomic list. All right, so a few names. Let's turn them into formulas. Sodium acetate. While we're at it, how about chromic acid? And while we're at it, how about diselenium? And then we'll do diselenium hexachloride. All right, so again, before we move on, you really need to know the category. If you don't know the category, you're not going to get the formula right. You got to know, hey, is this thing an acid, ionic, or molecular? So let's see if we can figure that out. Let me kind of help you out with that. So sodium acetate. This thing contains sodium. Sodium is a metal. If you contain a metal, you are ionic. All right, second one, chromic acid. What do you think that one is? It says acid. Oh, it's an acid. Chromic acid. Diselenium hexachloride. Oh, I see dyes and hexes and stuff. If you see prefixes, it has to be molecular. Now, we could confirm that by like going up here and going, oh, selenium, oh yeah, that's a nonmetal, and hexachloride, chloride is a nonmetal. Yeah, so they're both nonmetals. But, you know, if you see prefixes, that makes sense with it being molecular too. All right, you know, molecular one, let's go ahead and get rid of that one. Let's just do it, and then we can move on to the other ones. All right, diselenium. Di, what does di mean again? 2. Selenium is Se. So there's 2 seleniums. Hexa, what does hexa mean? 6 chlorides. Done. Se2Cl6, diselenium hexachloride. It's molecular. The prefixes are the subscripts. All right. I think we'll keep going backwards. Let's do chromic acid. All right, chromic acid. Oh, this is the converting deal. Ic goes with 8. So that means that I am looking for chromate. So chromate, 8. It's a polyatomic. So chromate is a polyatomic ion. I see it actually. I see it right here. Cr4 2- is what it says. Now, what's the other part of an acid? Because that's not the final answer. You still got to finish it. You told me it got chromate in it. That's fantastic. I love it. Thank you for doing that. But what else does acids always contain? It always contains hydrogen. So we're almost got the formula. Now we have to balance out those charges, don't we? Acids, you have to worry about balancing charges, just like ionic compounds. Hydrogen is +1, chromate is -2. What do we need more of? Hydrogens. So when you put it together, you actually are going to use 2 of them. H2CrO4. All right. H2CrO4 should be the formula for chromic acid. All right, let's do our last one. Sodium acetate. All right, sodium acetate. Oh, you got sodium, you got a metal, it's ionic. So sodium, you write the symbol for sodium. Na. It's +1, right? It's in the +1 column. I should erase some of this old stuff. All right, acetate, 8. Oh, wait a minute, that's a polyatomic because it ends in 8. It's on here somewhere. Oh, rats, where'd I put it? Oh, right here. Oh, man. Where is it? No, geez, sorry, a little technical problem. Here we go. Acetate, right there. All right, so that's acetate. So if I want to know the formula for sodium acetate, the other part is acetate. And what do you notice about those charges? I was trying to be a little nice to you. We've had enough, haven't we? As far as, man, it's been pretty challenging, I'm guessing. So what do you notice this time? The charges already, oh, they're already balanced. So we don't need any subscripts this time. Just Na2, I'm sorry, messed up. Na, and then it's just the C2H3O2. It should look like that. All right, so with that, that's it for naming. Wow, this has been quite a couple of lectures, hasn't it? So there's a lot to know. It's easy to get mixed up. So again, all I can tell you, you want to get good at this. I want you to get good at this. The best way of getting good at this is to keep practicing, right? So we'll get some practice in Zoom, and we'll get some practice on your sapling homework. And if you're confused, I will be glad to talk to you and do even more practice until it makes sense. All right, so hang in there. We're going to move on from naming in the next set of lectures. So we've learned all there is for naming. And if you're struggling with it, please let me know. All right, bye-bye.